Now we're going to deal with ionic compounds that contain polyatomic ions. Let's break down the word polyatomic. The prefix poly means many. And if we look at the word atomic and we take off the IC, we just have atom. So polyatomic is an ion that contains many atoms. So to break it down further, it's a group of atoms, so many atoms, with an overall charge, so they share a charge. They usually consist of a nonmetal, such as phosphorus, sulfur, carbon, nitrogen, and oxygen, and have a charge of -1, -2, or -3. There are a couple positive polyatomic ions that we're going to discuss, but we're just going to stick with the ammonium as the one exception for now. That's the only positive polyatomic ion that we're going to consider. Here's a list of them. Rather than going through the rules, I'm just going to simply give you a list at every time. You do not have to memorize these. They are simply there, and you have to know how to use them. So you're going to use the exact same rules that we use for the other naming of ionic compounds. We need to make sure that the charge balances. So magnesium is Mg, and if we look at the periodic table, it's right here. That has a +2 charge. And then nitrate is right here. It's NO3, so 1 nitrogen and 3 oxygens that share a -1 charge. So we're going to put that in parentheses. NO3 that all contain a -1 charge. And then we're going to do the crisscross like we did before. So that means we need 1 magnesium and 2 nitrates. So Mg1, but we're going to skip the 1 for now. The NO3, keep that in parentheses, 2. We want to keep the parentheses there because that's saying that we have 2 groups of these. If we didn't have the parentheses, we would just be focused on the oxygen. But because of the parentheses, we have the nitrogen as well. So let's take a look at some more. Aluminum nitrate. So aluminum is Al. If we look in the periodic table, it's right here with a +3 charge. So +3. Nitrate we just talked about is NO3 with a -1 charge. Crisscross becomes AlNO3. Keep those parentheses with a 3 on the outside. That's this one right here. Copper 2 nitrate. Now remember that 2 means it's the charge of copper. So we have copper with a +2 charge. Nitrate, once again, NO3 with a -1 charge. Crisscross becomes CuNO3 2 because of this 2 here. Right here. Iron 3 hydroxide. That 3 means iron has a +3 charge. We haven't talked about hydroxide yet. Hydroxide is right here on our list. It's an OH with a -1 charge. So OH with a -1. Crisscross. So it becomes Fe1 OH parentheses 3. And then our last one, tin 4. So tin is SN plus 4. We just looked up hydroxide. We know that's an OH with a minus. Crisscross becomes SN1. We end up dropping the 1. OH in the parentheses. And then because of that 4 there, a 4 comes down here. So one thing I want to show you though is that they typically end in 8s and ites. There are 2 exceptions. Cyanide ends in IDE and hydroxide ends in IDE. Usually when you end in IDE, it comes off the periodic table. These are things you're just going to have to remember. All the rest of them, if you see a word that ends in 8 or ite, you need to look on this chart. Alright, so let's have some more practice. So, Ca is calcium. We identify the cation and the polyatomic anion. So that's calcium. NO3, we've been talking about, is nitrate. So, does it need to have a Roman numeral? Well, let's take a look. Calcium is here on the periodic table. It's in a tall row. That means it automatically has a +2 charge. That means you do not need a Roman numeral. Name the polyatomic ion that usually ends in 8 or ite. So, NO3 we know is nitrate. So we have calcium nitrate. We have FePO4 here. This is going to be a tricky one. Fe is here. You need a Roman numeral in this area. So that means we need iron something. We need a number here. We're going to figure that out in a second. PO4, we can look on the chart again. Let's see, PO4 is right here. It's phosphate. Notice that you have more than two capital letters here. That means you have a polyatomic ion in there somewhere. So, put parentheses around your polyatomic ion because that's not going to change. Notice in the chart, PO4 is written here with a -3 out here. That means the phosphorus and the 4 oxygen share that -3 charge. So, PO4 is supposed to be a -3 charge. If we rewrite this like this with the parentheses and we uncross it like we did before, you'd have a +1 and a -1. But phosphate is supposed to have a -3. Because of that, that means it was reduced. So instead of being a -3, we have to multiply both sides by 3. So phosphate becomes a -3 now, which is what it's supposed to be. Iron then has to be a +3. That's probably the hardest one you'll get. Alright, so let's name some more. Look at our periodic table. Magnesium is right here. Since it's in a tall row with a +2 charge, we do not have to worry about the Roman numerals. SO3, however, we need to figure out what that is. So SO3, right here, it's sulfite. Once again, because of the fact that it was in a tall row, I don't have to worry about the Roman numerals. Magnesium again. SO4 this time. SO4 sulfate. Notice the difference of one oxygen changed the word. Ca, calcium, is right here. Once again, it's in a tall row, so we don't have to worry about it with the Roman numerals. ClO3, we have to figure out what that is. It's right here in our list. Chlorate. And there you go. Take a look at our periodic table again. Iron is right here. It's in the area with the Roman numerals, which means that we need to figure out what the charge is. So we know it's iron something. Then we had to look at what SO4 is. SO4 is right here. It's sulfate. Now we had to figure out what that charge is. If we uncross this, we have a +3 here and a -2 here. Those numbers came from down here. If we look at our chart, SO4 is supposed to have a -2. So that checks out, which means that iron must be a +3. Ba is down here. It's in the tall row that has a +2 charge. So that means I do not have to worry about the Roman numerals this time. Notice every single time I do this, I check to see where the metal is on the periodic table. You have to do that because that tells you whether or not you need a Roman numeral. So I don't need a Roman numeral on this one, but I need to know what PO3 is. PO3 is right... Oh, is it not on my list? Well, here's phosphate. It becomes phosphite. So the 8 becomes an 8. And because I don't have to worry about Roman numerals, I'm done. Lead is right here. Even though it's in a tall row, it's one of those exceptions that I actually do need a Roman numeral. So I'm going to put in lead. Put a space for the Roman numeral. And I have to figure out what CO3 is. CO3 is right here. It's carbonate. Now with this one, this was not in parentheses, so that means I'm going to rewrite it with the parentheses. That means that this is a 1 and this is a 1. Uncross those, we have a +1 and a -1. And if we look at carbonate, carbonate's supposed to be a -2. That means we have to multiply both of these by 2 to make it work. So that means carbonate would then check out. 1 times 2 is 2, so it'd be lead 2 carbonate. And that's how you deal with polyatomic ions with ionic compounds.